pit etiquette. He calls it dogcraft, and you know what? That's fine. But technically, Chris is correct. It is an engine.
I can't say anything.
No, but I can tell by that look. You know that look that Gunny gives the corporal when the corporal's doing something stupid and doesn't realize it quite yet?
Yeah.
But he doesn't want to embarrass the corporal because he's going to try and give him a break? Got a few of those. I had good guns. I've had a few bad ones too, but most of my gunnies were pretty decent folks. Now, to keep the valve centered in the port so it seats uniformly, I have a valve guide. And it does exactly that. It guides the valve up and down while keeping it centered in the port. And this guide wears, and it also wears the valve stem. So this is how the valve would go from in spec to out of spec. It's going up and down in this guide. Now, think about this. Our engines idle at about 750 revolutions per minute. Okay, think about that for a minute. That's spin. So this guy's going, and that's just at idle. Okay, about 350 because the valve, the camshaft operates at about half the speed of the engine. Okay, so this guy's going like 350 a minute. I couldn't do that, blow my elbows out. I already got bad elbows as it is. That explains my really bad tennis game. Right? So when I'm full load, when you got your foot buried in the throttle and you're
Running late.
yeah, okay. Says the guy who's sitting here trying to, right? I can see your eyeballs in the socket. Okay, running late. Your engine's rotating at about 1900 RPMs a minute. So yeah, you can see the wear factor here, right?
I would assume that you guys don't know your valve guides and what type of valve guides you use.
I'm glad you brought that up. That's a way back hot rod. I'm too cheap to buy parts. I'm going to get every last freaking wear out of this thing. Now, knurling, Mike, tell us what that is, buddy.
Basically, it's worn, so then you're pulling excess material out, and it's like in a coil, so it pulls the material out.
I'm roughing up the material.
Yeah.
If you grab a ratchet and the handle's real bumpily, that's because that handle is knurled for your grip. Now when I knurl it, I take a punch and I tap, and what it does is it causes a little bit of expansion of the metal. And that's just enough to get this to seal again until I get the car sold.
But it's not a solid valve guide all the way through, it's just bolted out.
No, these are solid guides.
No, not the knurling ones, though.
Oh no, they're up at the top and the bottom.
Yeah.
Ours are not knurled to my knowledge. The government does not sell
What are they?
knurled.
Are they steel valve guides?
Yep,
Oh.
steel valve guides. Now, these are insertable. In other words, if my valve guide is worn, I can pull this guide out, I can press another one in, and I use a tool that will cut it to a precise diameter, preparing it for the valve. It's called a reamer. That's right. You're about to get reamed, private.
Wow.
Oh no. Yeah, that's not good. At least he told me first. Now, reaming, a reaming tool is not a drill bit. It's not designed to cut the hole, it's designed to precisely size the hole. Reaming, for the most part, is done by hand. Do not put your reamer in a drill and think it's a drill bit, because you will muck up things. Just saying. Okay? Now, new valve guides are pressed into the cylinder head. Most new valve guides will need a reamer to cut it to spec. Yeah, I was having one of his to spec. Okay. The reamer may come in a kit with the valve guides, or you may have to go out and purchase it separately. It all depends on how you buy your components. Okay.
Some of them have like a jig you set up to
Yes.
guide you. Yeah.
Yes.
Yeah.
Now, so it guides the it guides the valve, keeps the valve centered in the port, and here's the rub. If I'm going to put a new angle here in my insert, if I want to recut the angle back to OEM, the original equipment manufacturer's specification, the stone, and it's going to be a sandstone, and it's going to go in a machine, and it's going to have a pilot to keep the stone centered in the port. And the pilot rides in the valve guide. Okay? And if the valve guide is worn, the stone's going to move around and I'm going to get an uneven cut. So prior to using this kind of tool to reestablish my valve seat insert in my head, I've got to make sure my valve guides are serviceable so this thing doesn't wobble and cut this ununiformly, for lack of a better term. So if you have aspirations of cutting new angles into your valve seat insert, which is absolutely done, first thing you should do is to make sure that the component responsible for keeping the stone centered in the port while it makes this cut is serviceable, and that is the valve guide. Make sense? So new valve guides can be pressed into the engine. So if I've got an old valve guide that's just way out of spec, and you can't save them, you can't resurface them. When they're worn out, they wore out. They've got a tool, it's got like a lever, it's got a little tool that goes down the valve guide, and a plate that goes on the bottom of it, and you just press it out. It's one of many ways to do it. They'll do, if you go to a shop, they'll use a hydraulic press and just press it out. Okay.
Is that the sound it makes?
Pretty much, yeah.
I just know that.
The technical term.
Well,
Right?
kind of like that. Oh, if I do that, my dog, oh, she goes nuts. So it guides the valve, it seals. Okay, it helps keep the oil from working its way down the valve stem into the combustion chamber. Now I'll have a valve guide seal, which will ride. This is the top of my head. My valve guide extends up above the top of the head. There'll be a rubber seal that goes over this that seals the valve stem from any oil thrown around under the valve cover, trying to work its way down the valve stem and get into the combustion chamber. And a lot of times when you have an engine that's burning oil, merely replacing that valve guide seal will help with the oil consumption. Not always, but a lot of times.
I've been reading on that on the engine in the car I just bought, and they're saying that a lot of guys were replacing just the seals, and it turns out they should replace the seals and the guides.
Possibly. It all depends on the engine manufacturer.
Yeah, because if the valve's wallowing around in there, it's going to wear out. And
Takes out the seal.
Yeah.
Yeah. And that makes sense. Now, if I'm just selling the car, I mean,
Craigslist.
why, if I'm selling a car, why would I do any expensive work to it?
Might as well
So
keep
you
it,
can
right?
sell it?
I'm going to do bare minimal to get it sold. I can get an oil consumption problem solved with valve guide seals as opposed to valve guides and heads and all that. I'm going to do it.
Why even go that far? Just
Stick
throw
it
2
up.
bottles of Lucas in there and.
Oh, fixing a can. Love that crap. That lasts about a week.
Yeah.
All right. So engine oil that works past the exhaust and intake valve guides can cause smoke problems. The valves to stick and burn. When a valve burns, that means exhaust gases are getting past the face of the valve, which is hardened, and they're getting around to the back of the valve, which is not. And it just starts,
Building.
well, carbon starts building up on the seat area, and if I've got debris between the interference angles, well, it's not going to seat. It's going to stay open, and I'm going to have low compression, and that just adds to the problem. So if I got low compression, low heat, I don't burn the fuel all the way. I got partially burnt hydrocarbons, and I got raw carbon just building up, building up, building up. Now, like we talked about Wednesday, the engine manufacturers have a way of trying to minimize that problem. They'll put rotators on the top of the valve stem. And every time the valve opens, it turns. So as it's doing that, it's cleaning the carbon off the seat, and it's not leaving the face, a certain portion of the face of the valve exposed to the maximum amount of heat all the time. By turning it, I'm kind of spreading the heat uniformly across the valve. Now, your automobile probably doesn't do that because it's not exposed to the kind of heat we're talking about these large engines operate at. Okay? So, valve seat grinding, again, if I'm grinding a valve seat in my head, the first thing I've got to check to make sure that that guide is within spec. So my stone that's cutting the seat into my insert doesn't do this. Okay. And I can also recut this valve angle here if I got enough valve left. If my margin here is thick enough, I can put this in machine, bring the tool out at the angle I want, and there'll be a gauge here that says, oh, you want 29.5 degrees, and it'll resurface this. Okay? Once I cut it, then I use a sanding compound called lapping compound. And what I want to do is I want to customize this fit to the valve seat. So I put it in there. I put this very fine powder, if you will, and I simply rotate the valve in there. I'm lapping the valve into the seat. So I'm taking out any imperfections from the cut here and any imperfections from the cut there, and I'm matching them. Once I've lapped a valve to its port, it stays there. So I lap it. Usually it's the tool to do this is a little suction cup on a stick, and then I just do this,
Like trying to start a campfire.
pretty much.
I've seen some guys that just take their grill, put it on low, just, you know, hook it
I'm-
onto the back of the valve, you know.
You probably could do that. I wouldn't, because you build up too much speed and too much heat. It's fine. And you have three compounds. You got light grit, medium grit, and heavy grit. So you start with the heavy, you go to the medium, and by the time you get to the light, it's pretty much a mirrored finish.
And
Now-
it's just powder?
Just a powder.
It's like in a.
It's called, they usually call it jeweler's rouge. But you can go to the store and it's called lapping. It's more of a paste, right? It looks it's kind of like toothpaste, but it's very gritty. I don't know what you brush your teeth with, but but you put the compound on the valve. You press it in its port, and you put some pressure to it, and you just go back and forth, and you'll hear it. It's now when I get done lapping the valve, I'm going to take and I'm going to put a dye on here, usually Persian blue. Some guys will use that white assembly grease. And I'm going to set the valve into the port, and that dye will tell me where the two match up. It'll form like a blue line. If the line's too low, I got to recut the angle. If the line's too high, it's not correct. So I'll know by the position of the dye ring around the valve seat whether this valve is going to be right in the correct spot in the valve seat insert. Okay? Now, if you're good at what you do, you'll do all this. If you're not, you'll just cut it and throw it in there. Okay? Now, a lot of people do that because they don't know how to properly do it. A lot of people do it because they're just lazy. Okay?
Just
So
gotta make sure you clean out all that lacquer.
yeah, you got to clean out the lap. You'll boil out the head, and it takes time to do this. Now, we used to do it.
How do you clean it, you said? How do you clean it?
You'll put it in a steam cleaner.
Oh.
Looks like a big giant dishwasher. It's got a basket that rotates. You close it. It's got this high pressure jet and a cleaning solvent. It'll clean the hand. It'll clean all the solvents and materials off of it. Okay. Now, you have to be able to determine your serviceability, and one of the ways you do that is you measure the diameter of the valve guide. Okay? So some grinding stones use the valve guide to center the stone over the valve seat. The valve's guide, prior to grinding the seat, you got to make sure the guide is in spec. So you kill two birds with one stone here. If the valve guide's not in spec, you know, okay, I gotta replace that before you cut an angle. Okay? So, for example, valve guide installed in a used head has a minimum diameter of 38 thousandths and 17 thousandths of an inch. The maximum diameter, the biggest bore it can be, is 38,003 and 1/10 thousandths of an inch. 383 thousandths and 1/10 thousandths of an inch. So you can see the difference between the smallest the hole can be and the biggest hole can be, not a lot. 6/10 thousandths of an inch. Okay. A newer rebuild, same story. Okay. So what you do to check the diameter of that valve guide is you have what they call a ball gauge or a split ball gauge. And what it is it's a two-piece unit that has a wedge that goes down between the two and forces the two components apart. So I run it down my ball gauge, down the bore, until I find the tightest spot. I lock the wedge where it's at so it maintains this dimension. I remove it and I measure it with an outside micrometer. That tells me how big my valve guide is. Okay. That's what it looks like. And you're measuring the valve guide. And it's got to split it, so it's a split ball gauge. Okay. Now this is why determining the serviceability of the head takes time. You're probably looking at 6 hours, if not more. Okay. What we do is we just get a reman head. We don't have the time. I know my guys have the skill sets to do this. Guys down at Rebuild are sharp. It's time. We don't have the time. Okay. So we'll take our head that comes off. We'll take it down to our vendor that supplies us with reman heads, and we get one that's in spec. The valves, the seats, the springs, they've all been checked.
The valve guides. and all.
Valve guides, everything. Okay. Now, here's a valve bridge with two valves. So when you're doing the valve lash on a valve bridge, that means I have two valves for intake, two valves for exhaust. I measure that with a feeler gauge between the valve rocker arm and the valve bridge. I don't worry about here to here. This spec is set at the time I install the valve bridge. Okay, and it's not touched unless I pull the head off, change a component, or do anything else other than a routine maintenance check of the clearance between the rocker arm and the bridge. Why do I need a clearance?
Expansion.
Heat expansion. Valve lash is necessary due to the fact that the metals will expand when they're hot. Setting that's too tight when the valves expand, they'll actually push the valve slightly off of its seat.
And the lifters, are they solid or hydraulic?
I'll get there.
Oh,
The clearance, did you set it up or you just come like that?
I'm sorry.
The clearance that you were talking about? the
This-
heat?
Right here?
No, from the bottom.
Here?
Yeah.
What about it?
You set it up or you just come like that?
Usually it's preset, meaning when I put the valve bridge on the valves, the clearance, whatever it might be, establishes itself. Okay, now on Detroit's, you had to set it at the time you installed the new valve bridge. Okay, so it varies from engine manufacturer to engine manufacturer. So, and I say this because, you know, it's, oh, that's how it worked on a Cummins, so I'll do that on a Cat. Maybe, maybe not. You better check. Right? So on a Cat, or on a Cummins, I just dropped the thing on there. On this family series of engines. Okay? It might be different on an A series with 4 valves per cylinder. Okay?
I've not seen a Cummins with an adjustable bridge. Max had them,
Max, Detroit's, the old two-strokes.
Yeah.
I can't speak too much to Caterpillar.
Yeah.
Okay.
I don't have
So
one.
if my lash is too loose, then 3 or 4 degrees of rotation that should be opening that valve, allowing it to breathe, are used to make up the excess clearance. And that exactly will result in a horribly running engine. You guys have sent valves all the time for a bus that comes in running back. And you run the overhead, check the lash, and that clears up the problem. Or a portion of it. Okay.
Low power, rough idle.
Yeah, smoke.
Yeah.
So checking the lash on a 4-valve head. Here's my valve bridge. Here's my rocker arm. Here's my feeler gauge. Okay? That's how you check it. Right on the valve bridge to the rocker arm. And we'll do that when we reassemble it.
What kind of engine do we have now on our,
ISLG,
is it not Detroit?
No.
right? It's at Cummins.
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 No, not Cummins. Cummins.
Cummins.
Cummins.
Yes.
Because if you go to a Cummins dealer and you call it a Cummings, he will escort you out the door. Oh, we don't sell Cummings. This is not Cummings.
Cummins.
This is Cummins.
That's the injection seat.
That's just the way they are.
Is this building?
Yep. Cummins. And our particular engines are Apex Red. That's what Leroy Carr, he's a trainer out at Bloomfield. He's like, remember, it's not just red, it's Cummins Apex Red. I'm like, gotcha, Spock. No problem.
This is diesel.
Okay.
Hey, Mike.
Yes, sir.
You were talking about maybe sometimes the springs get too loose, causing
Too weak.
too weak, causing a leak down
Yep.
issue. Couldn't
Yep.
you just replace that spring right there and then?
Absolutely.
And is that done here
No.
or?
So I'm glad you asked that question. Depending on what I'm doing with the truck or the engine. Let's say I've got a budget to replace 3 trucks this year. Okay? But I've got 6 trucks that are And I've got to get 4 more years out of them before I can budget for replacement. Okay? I don't want to spend a lot of money on these trucks because I'm not going to have them long. But I need them to run okay. So what I may do, if I have a truck that's running particularly bad, okay, and that's not the one slated for replacement, I would probably do a leak down, find out what my percentages are in leak down, and if it's failing, I'll have the head taken off. I'll bring a new head on board, and on that new head will be new valve springs, new valve seat angle, new valve face angles, new valves, and new valve guides. I'll plop that head on there, and hopefully that will improve the running of the truck until I can sell it. Now, if I'm really desperate for cash, I'll find the particular cylinder that's giving me a problem, and I'll replace the components necessary, like the valve spring, and see if that brings that cylinder leakage problem back into spec. Okay? Because you can change a valve spring with the head still on the engine. You've got to bring the piston up the top, fill it up with air, compress the valve spring, take the guides off, or the lock,
Yeah.
and then pull the spring out. Put the spring on, put it back together. Right? And then if that
Corrects it.
then I get a little more use. Is that the desired fix? It all depends. It goes back to, if I'm going to sell a car, why put a lot of money in it? If I'm going to get rid of this truck in 18 months, I sure as hell am not going to put a $16,000 motor in it. All right? Engine. Love that little gunny. That's awesome, man. I don't even have to see it now. I just feel it. So it goes back to if I plan on keeping this engine for a while, I may just go through it. But if I've got it's only got to last 18 months, and I'm going to change the run where it's not going as far, as much load and all that, I'm just trying to, I'm beating a sick horse, then I'll do the bare minimal to get it running. And then when that fix starts to fail, it's probably time to sell the truck. Make sense? Good question. Now, pushrod tubes connect the camshaft to the rocker arm. Some engines, they don't care. Some engines will have a separate pushrod tube for the exhaust valves and a separate one for the intake valves. Okay? Up to the manufacturer. This is why when you're disassembling the engine, you should look carefully at these parts before you rip them out of the engine. If it's got a yellow band on 6 of the 12 pushrod tubes, then it must be a reason. So I'm going to make sure I put those back in their
Proper.
their original location. And that's another thing. If I'm reusing a component, okay, I'm going to reinstall it back into its OEM position, original equipment manufacturer position, because whatever's wearing against that is married to it. So they have a unique wear pattern. Okay? So here's my cam follower lifter. Okay?
Those inspection.
Now, that particular lifter came out of the board, it's married to a particular lobe, and it's established a custom wear pattern between that follower and my camshaft lobe. The lobe is what pushes the follower up to push the push rod up, to push the rocker arm down to open the valve. These lobes. Okay? So if I'm going to reuse that, I got to take and note what position is it in. Cylinder 2 exhaust, cylinder 3 intake, whatever.
Or get some serious cam wear. That one,
I possibly could. If I don't take note of where they come from, I can put them back in the engine. Oh. Okay? I can put them back in the engine. It's just, now it's not married to the original lobe.
roller lifters though, it doesn't matter.
Yeah, but we don't have
I
rollers.
know, I just.
Detroit did.
Yeah.
They had
We
roller
still put them back in the same hole.
Yeah, you still put them back in the same hole because that roller has got a custom wear pattern on the lobe. And I want to reestablish that. I want to maintain that.
Well, that's gonna be hard to do because we pulled them all out.
Yeah, yeah. Well, when we do ours, we'll be able to pull them out one at a time. We'll pull them out one at a time and you can number them and then you put them back in. Now, if I'm using new ones, then who cares? Okay. Now, generally speaking, you shouldn't, but it's done, put used components against new components. So if I replace this camshaft, right, I don't want to put new old used followers against a new camshaft. Because whatever irregularities are in here are going to transfer to here. Now, is it detrimental? Will I lose the motor? Probably not. It's just a good practice. It goes back to your budget though. Now a set of these isn't a lot. But I guess it depends on your budget size. I got a fixed amount of money and I got to do a job and I got to cut corners to get it done properly, then I may consider reusing them. Maybe.
Is that softer than that one?
That's a very good question, and I'm going to say no. I don't think so.
That one's softer.
So,
No, they're about the same as far as hardness.
so that's a solid lifter, so the adjusting the latch is a little more critical.
It's extremely critical.
Then the hydraulic lifter is not as.
You wouldn't
Because
see
you have
hydraulic.
more leeway.
Well, you wouldn't
Yeah.
see hydraulic lifters in these large engines. They just don't hold up well.
Yeah.
And if you had hydraulic lifters, you don't really have a valve adjustment. Because every time you start it up, you give it a valve adjustment using oil pressure.
Yeah. Now the gasket is, yeah, it's extremely critical. Thank you. It's extremely critical. It's the seal between the top end and the bottom end. It seals my oil passages from my coolant passages. It seals the combustion chamber so I don't get leakage between my head and my block. Okay? And it's a very complicated design. It's not just, a piece of steel in there. It's got multiple layers in it of different materials designed to do different things. Okay? So the gasket's complicated design, and it's a no retorque. So back in the day, when you rebuilt your Chevrolet, Chevy would tell you, okay, put this gasket on, and after 500 miles, retorque the head. Or 1,000 miles, whatever it is. You take it back to the dealer, and they retorque the head. Okay, that was a retorquable gasket, and that's how they were for quite some time. This gasket is a no retorque. So if I put the gasket on the block and I put the head on and I torque the head and all of a sudden I realize, oh crap, I've got to take the head off because whatever, got to get a new gasket. You can't, well, I just put it on, I'll just, no. It's distorted, it's been crushed. And if you uncrush it by pulling the head off, it's not going to seal up again the second time.
You may not torque it down exactly the same.
Now, it's to seal the combustion chambers. It's got multiple layers. It's got a stainless steel armor coating on the inside, elastomeric sealing bead around where the head bolts and the passages are, rubber fiber facing to make up this part, wire combustion ring right around the combustion chamber, and a solid steel core. I mean, this thing's pretty stout. Okay? Now, one of the things we have to do to make this thing seal correctly is my cylinders are replaceable in my engine. Okay, I can pull the liners out. That makes up the cylinder. Let's see if I got one floating around here somewhere. This is my liner. This is a Detroit 60 series liner. I know it's Detroit because the logo's down here. It's not that I'm smart. See, I could have played that off. Yeah, being honest. I don't want to disappoint anybody. Wow, I really thought you were smart.
You read the logo. Come on, you're so
I can't read, yeah. All right. Gunny, that's the nicest thing you've said in all year. I'm paying for that one later, though, trust me. Hey, I'm going to pay for that. Now, liners they protrude up above the top of the block. It's called liner protrusion. And that protrusion is a very specified value because I have to give this head gasket, where am I at? I have to give this head gasket something to crush around to seal the top of that liner to the bottom of my head. Right? So each manufacturer is going to have a certain amount of height above the block that this liner is going to stick up. So I got something to crush around. Now, some manufacturers, like Cummins, it's a pretty loose spec. Something like 24 to 68 thousandths of an inch. Might as well be the Grand Canyon. So you could pretty much drop the liners in the block and they're pretty sure going to be there. Now you've got to check, obviously. Detroit, on the other hand, they're a little more persnickety. Like that word? Off dictionary the other day. I even looked it up. Persnickety. They're a little more precise on what they want. 5 to 15 thousandths of protrusion with no more than 3 thousandths of a difference between two cylinders. So if this one's at 5 and this one's at 8, no bueno. Because the head gasket's not going to be able to do this. Right? And that's the thing about Detroit. So I'll sink this one in its hole and it's like, okay, I'm at 6 thousandths. And I sink this one in. Oh, I'm at 12 thousandths. I got to dial this one in.
Isn't there like some type of tool to
Yep.
crimp them down?
No. When I put this in to measure it, I've got a tool that goes across the top of it.
Yeah.
And the 2 bolts will go in the head bolt holes on the block, and I'll torque it to a specified value.
Oh.
What that does is that sinks the liner in the hole and puts some tension on it to simulate a head being on top of it. And then so I'll bolt that in, and then I'll measure the protrusion. I'll have a gauge. I zero it on the block. Then I lift it up and I put it on the liner, and it'll tell me how much higher the liner is than the block. That's my protrusion. Now with Detroit, I'd sink it, and all of a sudden I put 1 in, 2 in, 3, and 3 is way off. So I adjust 3 by changing 2, but now 2 and 3 are good, but now 1 and 2 are off. So now I got to change 2 back to 1 and change 3 to match 2. And then I go to cylinder number 4. And I play this game all the way across the block until I get the protrusion within spec and the difference within spec.
So before putting the head on, and you put those sleeves in, it's okay for those sleeves not to be completely flat with the block. Because like on a gas motor, they'll resurface the block. It's
Yeah,
gotta be
different,
flat.
and,
So those. they
well,
need
we're
a
still
gasket.
gonna flatten the block, cause I gotta have a flat surface.
Uh,
So I'll still machine the top of the block,
yeah,
and I'll still machine the bottom of the head to make it flat.
but the gasket allows for.
The gasket's
some
designed
Yeah.
to have something to crush around.
And so
if
those
this were
can pop
perfect-
up above the surface of the head a bit.
A bit.
That's okay.
That's the key word, a bit.
Yeah.
If this didn't ride above the surface of the block, there would be nothing for that gasket to crush around.
Oh.
Nothing.
That's
Oh,
why-
so
that's
it's-
why you want it
it's
to be
sealing,
raised
it's
a little
sealing
bit.
the sleeve too.
Yeah, oh yeah, absolutely. Absolutely. It seals the sleeve because this is my
Yeah,
combustion
so you
chamber.
want it to protrude a little
Yep.
bit to seal the sleeve.
Seal the sleeve to the bottom of the head,
Yeah.
right?
If it didn't have a sleeve, that'd be a different story.
Be a different story.
Yeah,
Be a differently designed head gasket.
yeah, okay.
Okay? So I need that protrusion there for the head gasket to seal correctly. Let's take about 10 minutes